All right, guys. In this video, we're going to look at how to assess regression line, as in which regression lines are going to be good. Is our regression model that we fitted, is it a good indication of linearity of the data set? That's kind of what we're going to be talking about today. So we're going to talk about two things: residual plots and R squared. Right? Now, if you look at the notes, I kind of skipped some of this stuff here, but that's because we're doing this in class, right? We need to actually get the data before we can fill this out. So we'll do that during class. We'll kind of calculate some of this stuff. Use our calculators a little bit. We'll go from there. So what is a residual plot? A residual plot is a scatter plot, so this type of scatter plot of the residuals against the explanatory or predicted predictor variable. Okay, so you're going to graph your residuals, right, as against the explanatory variable. Residual plots help us assess whether a linear model, put that in capitals, linear model is appropriate. So when you do a residual plot, and we're going to talk about a couple things. I'll show you a couple of examples. When you look at a residual plot, it's only going to tell you if a linear model is good, not any model in general. See anything else? Yeah, so this only tells you if a linear model is appropriate. So what are we going to look for? Any type of pattern is what we're going to look for. So if you see any pattern in your residual plot is a red flag. Okay. So I'm going to do a couple of examples down below, and you'll kind of see what I'm talking about. So if I have a residual plot and it looks, so you have a graph, okay? And the reason why I'm drawing my graph like this is because you're going to have some positive and some negative residuals, right? So positive are above the x-axis here, and negative are going to be below. And in a perfect world, you're going to have a residual plot that looks something like this, okay? Where you kind of have just dots scattered all around the line, right? In an ununiform, right? If you give this to someone, you'd be like, oh, is there a pattern between these? You're going to be like, no, probably not, okay? This right here is good. This is what we want to see. Okay. Now, what are some bad ones? What other patterns could we look for? So obvious ones are going to be stuff like if you have your residuals go in a straight line. So if you know you have residuals like this, clearly this is a pattern. Right? These are some of the more obvious ones. Okay. So that's a bad one. Another bad one would be if you get like a parabola once you do your residual plot. So you get something like this. Okay. Now some less obvious ones. Okay. If you have like little distinct clusters, this is also be a bad thing. So let's say you have something like this, and then you have something like this, where you have two distinct little clusters, right? These are all bad. These are all bad residual plots. This is not what you want to see. Okay, so that's another common one you can see. Patterns. Oh, the other bad one that I want to show you is if you have something like this. This is probably going to be the most trickiest to see. And we'll kind of talk about this in class, but I want you to think about what's the pattern that you're seeing here. there is a pattern here, and I want you to think about what that pattern is, okay? So something like this would also be bad. Okay, so again, the goal of our residual plots is going to be to show no pattern, complete randomness. And why is that the case? Because what we're saying when we look at this left-hand plot over here is that our residuals underestimate and overestimate equally, right? So in some cases, we're gonna our blind's gonna predict too much, and in some other cases, our blind's gonna predict too little. That's a good thing. That means we're kind of going right down the middle. Okay, moving on to the next thing. What is the standard deviation of the residuals? So got a little equation here. We have S equals the square root of the sum of all the residuals squared. So you take all the residuals, you square them all up, and you sum them up, divided by n minus 2, n being the sample size. So if you have 50 people in your thing, you have 48 as n minus 2. And this is the same thing as the square root of, to calculate a residual, you have your predicted value minus your observed value. Or sorry, observed minus predicted. So you have yi, so the individual y value minus the predicted y value squared over n minus 2. Okay. Those are the equations. And now what does that mean? Okay, we're not going to normally calculate that by hand, but what does that mean? What it means is that this tells you the approximate size of a typical prediction error, right? Standard deviations are a measure of spread of how far you are away from the mean, with the line being the mean is kind of typically how far you're going to be away from that line. Okay. So the next couple of questions, again, going back to the candy activity that we're going to be doing in class. Last thing I want to talk about is R squared. And what R squared is the fraction of variation in the values of y that is accounted for by the least square regression line. Okay, so what else we could say about this is that it is used to analyze the differences in one variable, and how differences in one variable can be explained by the differences in a second variable. So if you have a perfect linear data set, R squared is going to equal 1, which means that 100% R squared is written as a percentage. So what that says is that 100% of the variation in the data can be explained by the explanatory variable, in this case x. Okay, so if R squared was equal to 0.336, for example, okay, we're saying that 33.6% of variation in y, whatever y is, okay, is unaccounted for by the LSRL using some variable x. Okay. Another way of saying that, if I go 1 minus that number, I get 0.644. is equal to 0.664, which is also saying 66.4% of the variation in the y, whatever y is accounted for by the LSRL using X. Okay. Last thing, how's R squared relate to R? They're literally the square of one another. So if I take the square root of R squared, I get to R. Okay, but both are measures of how well a line typically fits. Okay. So yeah, that's the end of this video, guys. And I will see you in the next one. If you have any questions, let me know.